Hello, Internet. Welcome to the technical interview key point review. Today, we're going to be looking at linked list. Linked list is a very popular topic in technical interview. Interviewers seems to love this topic and they love to test it. The reason being, it's a relatively easy topic and there are limited methods or algorithm you can mess with a linked list. And the difficulty of it is easy to squeeze in a 45 minutes interview so that you can go in, solve the problem, write down the code, everything is done. It's better for them to evaluate you. So linked list right here is very important. And I suggest you to go ahead and practice all the questions you can find, which there are several category and there are just several algorithm. All the questions are actually the variation of those algorithm. So you don't need to remember quite a lot, just be smarter and implement the algorithms you know in real life. That said, let's review what you need to know about linked list. So what is linked list? Linked list is essentially a collection, not a collection. It's essentially constructed by list node. What is a list node? List node, or simply node, depends on how you want to call it. List node is what I used to. List node is essentially just a reference. This plus sign here. This is a public sign. So essentially, it's a reference to next, which is also a list node, and a reference of data of any type you want. And other things. You can have multiple things. You can make the list node do things that it makes sense to do, and other maybe even methods. You can make it do whatever you want it. But the most important thing is reference to other reference or references, depends on what kind of linked list it is. Reference to other list node and the things you want to store in it. Now that said, linked list has two kinds, as I mentioned. The first kind is a list node linked to next one, linked to next one, linked to next one, so on and so forth, until the end. Assume this is the end. And that's a singly linked list. There is only one-way reference. The previous node only has reference to the next one, and the next one has no reference to the previous one. Doesn't have this. And the second kind linked list is, you can guess it, is a doubly linked list. As the name suggests, it has the reference to both of its neighbor. So the previous one has a reference to next one. Next one also has a reference to the previous one. They can find each other. And the runtime, the time complexity on both linked lists, they're the same. For search, since you have to iterate through, basically, if you are searching, there's only one way you're searching it. Just iterate through until you find the node you want. And iteration, how long does that give us? It's O(n) time. That's the time complexity for search in linked list. And what about insertion? Insertion is if you have two reference, say the two reference right here. If you want to insert another node, all you need to do is break this one and link this here and link this here. So that is a constant time operation. That's a O(1) operation as insertion. What about deletion? Deletion is the same thing. Say if this one, we want to delete this node right here. All we need to do is break these and link them together. That's also a O1 time. That's also a O1 time operation. When you go into interview, remember to check with the interviewer what kind of linked list you are getting. If you're getting a singly linked list, you don't have the reference to the previous one. So you have to be careful and ask, clarify. Clarify is very important in interview. Clarify with the interviewer what kind of linked list I have. What is it? What have you gave me? That's it. Are these the only two kind of linked lists we need to worry about? Yes? No. The answer is no. There is another kind of linked list. I mean, it's sort of, it's not another kind, it's just kind of special. You're not ugly, you're just special. All right, what the linked list look like is it has a loop inside of it. So if we iterate through it, we see this, we see this, we see this, we see this, and we have reference to the next one, and we have reference to the next one. This one already appeared, and we have a loop in the linked list. Sometimes you need to check with the interviewer, hey, the linked list you gave me, can there be a loop inside? If you ask that, the interviewer will be impressed because a lot of people ignore this kind of situation. And what I want to talk about is another kind of a algorithm of checking if there is a loop inside of the linked list. And this algorithm is used in multiple places, in multiple questions that you can use. The algorithm is called fast and slow runner. I guess it's plural, fast and slow runners. What is it is 2 pointers. It's essentially 2 pointers, pointer 1 and pointer 2. How are they gonna work to check if there's an infinite loop? Okay, easy. You initialize them at the same point, and the fast runner, let's call it PF, and this is PS. This is the pointer slow and pointer fast. So the pointer fast will go 2 nodes per time. They will go 2 nodes per time. They will call P every time you iterate it will be PF equals to PF. Assign PF's next to PF, and you go 2 steps ahead. And PS is a standard pointer. Every time you iterate, it will just be PS next. So it goes 1 step ahead. And with a faster and slower runner, eventually, if there is a loop, eventually they will meet at some point. And if they ever meet each other, you can be sure that there is a loop inside. And that is, ladies and gentlemen, fast and slow runner. You can implement this in a lot of places. For example, fast and slow runners, you can have like a 1, 2, 3, 4, 5, 6, and this is node 1, node 2, node 3, node 4, node 5, node 6. And the interviewer will tell you he wants it to be something like node 1, node 4, node 2, node 5, node 3, node 6. How do you use this fast and slow runner to make this that? Think about it. It's very easy. If you can solve it, good job. But I'm just saying, this thing right here, this algorithm is used in multiple places, and do not forget it. Okay, so in most cases in interview, you are solving a linked list problem with a loop. More specifically, most of the time is a while loop because you are iterating through them. And, because linked list doesn't have the instant access time. So basically, you're just looping through the linked list. And most likely, you're using a while loop because the last node in linked list will be linking to a null. That's how you know it's probably time to stop, right? But sometimes when the question gets difficult, I mean, gets counterintuitive, let's put it that way, you probably want to think, is there a sub problem? Do you see where am I going with this? Yes, I'm saying sometimes if you can't make the link between while loop and the sub problem, probably try a recursion. Try a recursion. Because as the wise man said, every recursion can be solved by a while loop. Every while loop can be solved by recursion. So when a while loop becomes counterintuitive, probably it's time to try, hey, maybe it's time to use a recursion, right? This is important. This doesn't occur a lot, but you have to remember, if you get stuck in interview with a while loop and linked list, you probably want to think, hey, can I figure out a sub problem here? And probably I can do a recursion with it. Oh, and I almost forgot. There is actually another very important thing to see here. Oh, what is happening? There's actually another very important concept to see right here. I mean, it's a reminder. It's a reminder. It's when you, all right, let's make some space. It's when you are deleting or inserting. When you're inserting a node, remember to check if you're inserting it at the head. If you're inserting like right, if you're inserting it right here, if you're inserting it here, then you want to move the head. Remember, this is a head. That's the entry point of the linked list. You want to move that to the one you just inserted. And the other situation is when you are deleting one. When you are deleting, I probably shouldn't draw this much node, but whatever. All right, if you are deleting one, so you are deleting this one, you want to set this one next to null. And just remember that. If you were deleting the first one, also remember to move the head. That's a reminder. Some people forgot to deal with this, and it's not looking good. It's something you need to know. Like, this is so basic. This is so basic that you have to know about it. All right, ladies and gentlemen, that's it for this episode. I'm gonna see you next time. Thank you very much. Don't forget to subscribe. I love you.